side. So in the load side, we have to be properly tuned. Then only we are getting the signal through the transmission line in proper way. So this introduction part I have given, you can see the transmission line are used for low loss transmission for microwave power. So what is the microwave power? Normally power is equal to voltage into current. So all signal in the form of the electrical format. So when it transmit on the free space, it will be in a photonic format. So again, another question you can see: are two conductors required for the transfer of wave energy? Definitely. Okay, definitely. So you can see the general solution for that only we are studying the wave propagation equations. So normally called as wave equation, we have studied this part also. Can see there is a two time dependent term e to the power j omega t and e to the power minus j beta z. So in the first term e power j omega t, time is the variable term, where in second case e power minus j beta z is the variable term. So based on that only the wave has been segregated like TE, TM and TEM. Okay, TEM. So for that some solutions from the partial derivative has been given. Usually in a descriptive type, these derivations are very important. Okay, but this time you cannot able to do this derivation and you cannot write this thing on the answer sheet also. It is not that much important too, since in descriptive type usually they will ask this part. Okay, so you can see the TEM or TEM mode. So you can see the condition: electric field also zero, magnetic field also zero, where K is nothing but the wave number. It is a non-trivial solution. So which means that it not exist with any of the field component. Okay, and also you can see wave impedance is in general, not the characteristic impedance of the line. So the wave impedance is nothing but what signal, which will be denoted as the three-dimensional quantity. So for each signal has some resistive power. Okay, so it cannot be interfered with anything. If the best example for the wave impedance is the nowadays we not seeing some small cuckoos, okay, small sparrows on the roadsides or else in a remote area or else any other. Only in villages we not have that much towers or any other units, so that the radiation is minimum in the village sites. So there you can find the small sparrows, small species. But in city side, if you see, we cannot be able to see the sparrows or anything else. Why means due to this type of in many places they have deployed the tower. Near to the tower, we are seeing nearby homes also there. It is very much cautious to everyone that radiative power will affect some characteristics of the vessels. Okay, this will be happen. Okay, so on other end, the researchers and academicians and the industrialists are trying to reduce the radiation from the spectrum. Okay, in a transmission line, how they are getting the solution they have mentioned, you can see solving the 2D Laplace equation. The equation has been given. The Laplace equation and all we have studied in the first unit, and then they have drawn the tangential to the electric field and normal to the magnetic field, and finding of the intrinsic impedance by using this formula, then finding the voltage and the current, and at last the propagation constants and the characteristic impedance are been calculated. Okay, this is one type of procedure for analyzing the TEM wave. For TE waves, some procedures are there, like solving the magnetic equation by using the Helmholtz wave equation and dispersive wave impedance and dispersive phase constant. And some of the general property has been given for TM waves, and you can see some criteria are being given. So just look, scare with these formulas. It is just the procedure and what all the matrices are being calculated for each and every cases they have given. For parallel plate waveguide, the line parameters has been calculated like a total current, no voltage difference from top to bottom, and it is the characteristic impedance and phase velocity. So these are the waveguide structures based on the wave equation. Don't be look on these equation. And in this case, I want to tell one condition. You can see this is your waveguide. Always in waveguide, the three important model parameters will be there. One is the phase constant, cutoff frequency, and the wave impedance. Okay, so you can see this is your dimension. It is okay, and you can find the phase constant and current cutoff frequency and then wave impedance. Okay, and another thing called as the dominant mode. So what is meant by the dominant mode? Usually the word dominant is nothing but something getting ownership. I am doing. I only done. I am better than the other. Like that, dominate with others. Okay, so that is called as dominant. Like that, in a waveguide, you can see a condition A greater than B. What is A greater than B? It is a dimensional thing. A is greater than B. Okay. Yeah, and another thing, there are various modes are there like TE00, TE10, TE11, TE01, like that. Many types will be there. Like each modes, TE, TM, TEM, almost everything has the um, that is many modes, but in which mode we will get a maximum signaling for the rectangular waveguide. I'm not telling about square waveguide or circular waveguide, rectangular waveguide at A greater than B. Okay, A greater than B. So your mode calculation is it come like this, that is TE10 mode. Okay, and these are the equations. Don't look on it, just have a look. Okay, so just to see these equations alone. Sorry, it has been went up. Yeah, so come to this different types of technology. So if you go to your motherboard, there are many of the chips, then many of the circuits has been there in your motherboard. So in some units, maybe like a strip line or the micro strip line. So there also have some fringing effect. The fringing effect is nothing but this type of mode patterns only, TERTM or TEM. So from this also we can find out what is the meant by the discipline. You can see the TEM fundamental mode is TEM mode will be there. And the strip line also support the higher order TM or TE mode, which are avoided in practice. Approximation format okay for analysis. Okay, so so you can see the does the strip line have the higher order modes or not? Definitely, it has the higher order modes, and the structure of the strip line actually perturbation of the parallel plate waveguide, which has TE0 or TM0, actually not 0, just okay. And also you can see the micro strip. The most popular planar transmission line. Actually, what happens is that you can see at the middle, the strip will be there. When we are applying the potential, first it will be the conduction will be goes here. Okay, so this is your strip line. This is the respective calculation of the strip line. Actually, usually you will study the strip line separate in your antenna structures also. This is the base formula with respect to the width and distance ratio. Okay, some problems has been given. No need of problems. Okay, you can see thus the microstrip has the higher order mode. You can see in a closed microstrip there exists the dominant called as the quasi TM mode. So dominant mode only it is also here. Here also dominant mode exists, but the quasi that condition is called as the quasi. So you may ask one question: what is meant by the closed microstrip and the open microstrip? It is based on the circuit connection and disconnection. Okay, it is a closed loop circuit. Okay, and other than the transmission line and waveguide, you can see the TEM modes, the ridge waveguides will be there, and for this also this type of calculations have to do. Okay. The slot and the coplanar waveguide. Okay, for a slot, also the quasi TEM modes are available. Students, one more thing I have to tell: whenever you preparing this thing, some common matrices and the common points will be there. That should be you have to be remembered properly. So it maybe get confused. Okay, so you just while you preparing, you just write it and prepare so that it will be really useful so that you also understand the concept in correctly. Okay, there are different modes like coaxial, waveguide, strip, microstrip. They have given different modes: dispersion, bandwidth, loss, power capacity, physical size, ease of fabrication, integration. So how it can be done, and what are the basic matrices and basic thing has been compared. They have shown it like this. And each condition's characteristics has been given. You can see. So this is the basic things, and these are the some of the Bessel functions. Maybe this not equal. Mostly, this is by using some experimentation only. It can be done. So just look on it. It is not that much useful for you peoples. Can come with the applications of the circular waveguide mode. Can see gyrotron. It is generating for millimeter and terahertz radiation source. So in this case, um, these are the modes can be applicable. Similarly, the millimeter wave device. So for rotary device, these are the modes can be applicable. So circulator and isolator, TM11 and TE11. Okay. For plasma applicator, these are the modes can be applicator and microwave and material applicator. These are the most can be applicable. So some of the applications, mostly in this type of application, we are showing it is highly efficient, low reflection, modest purity, and the broad bandwidth. Okay, so these are the best applications of the TEM modes. Okay, so these are the things that you have to look in your uh, so in last part alone, you have more theories. Okay, in a transmission line, you have more theories. While you preparing, you have to be thorough with the basic things alone. Okay, don't confuse with all formulas. Okay, here you no need to concentrate on the formulas. The only thing is that comparatively you have to study with all the waveguides. Okay, and in tomorrow's class, I will give neatly about the theory part, so that after that we have some test on it. So this document, and additionally I will put to you the theoretical content also I will put, so that you can read it instead of looking on the equation. You can read it, and from that you may expect the question and answers. Okay, so this is the last part of your syllabus. Okay, so we will go next class also.